My name is Schumann. I'm the founder and CEO of RSS-Hydro in Luxembourg. We specialize in Earth observation of flooding and computer simulation of floods. We work with the humanitarian sector, international response teams. We also do maps for insurance and private sector as well as public sector. So here today I want to present to you Floodscan-DTX. It's an idea we've been working on for quite some time. It stands for Digital Twin Experiment, and it's about an efficient AI flat mapper for operational SAR satellites. So let me tell you a little bit more about this. As everybody knows, floods are very impactful and are actually one of the most frequent natural disasters, and definitely the costliest one on an annual basis. So images like this is Beira in Mozambique in 2019. It was very hard hit, as you probably all know. So images like this are very common, and with climate change they probably look a bit grimmer in the future. So what can we do about it? I think there's a lot of talk about Earth observation. It can be almost as the holy grail if you know how to process it. The large coverage is of course ideal. So let me tell you a little bit about FDL. FDL is the Frontiers Development Lab, sponsored by ESA in Europe. So last year there was a very cool challenge that relates to this talk, and that's why I want to talk about it here. They used an AI flat mapper trained on Sentinel-2 optical imagery to go on a GPU chip that could be on CubeSats like FiSat-1 here that was recently launched by ESA. And the team of students and postdocs actually did so well that we got invited to submit to a special issue by Nature, and it's currently under review. So things like this would be game changer, of course, for the humanitarian sector, right? You would have a flat mapper on board a satellite, so no latency anymore, no big wait time. So, and of course, during floods, SARs, as shown here, so synthetic aperture radars, we carried on board satellites like Sentinel-1, or even ISI commercial satellites are becoming very much more popular because they see through clouds, light rain, and during night as well. So these are maps produced by Copernicus program, for example, emergency mapping services. Then these maps are typically available online for the humanitarian community to use. Then the headquarters of, for example, the UNWP sends it to their country offices. They then send the map to the field. So all of this still takes way too much time. So how, even if you have it on board a satellite, the flat mapper, how would you get it down to Earth? Well, there are initiatives like Emergency.lu, which is an initiative by the Luxembourg government together with a communication satellite provider. They can deploy antennas like shown here in the field to re-establish communications via communication satellites. So these satellites, of course, can also downlink data in a matter of minutes. And so if you put all of these things together, so AI on board a satellite, this time we're looking at SAR here, and having that processed in a matter of minutes. And then, of course, with SAR, you would have to process in SAR geometry rather than in auto-rectified geometry. So that is a challenge, but nonetheless, it's feasible, we think. So the ML algorithm can be trained on images on Earth, and the ML model trained can be uplinked to the satellite, where it does its magic with the images turned into flat maps. Then that flat map could be processed into vector points, easy to be sent to a geostationary communication satellite and sent down to Earth to receiving stations in a couple of short SMSs or something like this. That could then be transmitted to a mobile phone app that puts back the flat map from these XY vertices, for instance, and the rescuer would have that mobile app in his or her hands to be told where to go for the next rescue. So we think this idea is feasible. Designing it, prototyping it is feasible. Doing the AI mapper is, of course, the main thing here. So we submitted this to the ESA program, EO Science for Society, and it's currently under evaluation. So thank you very much for listening. I hope you like it. If you have any questions, feel free to email me or